In this video, we'll be learning about operations with polynomials. But first, let's start with a quick warm-up. Go ahead and pause the video, give these problems a try, and then come back to check your work. Right, now that you've had a chance to try these, here are the solutions. Now your work might look a little bit differently depending on how you approach the problem, but you should end up with the same final solutions. So here is our essential question for today. We want to figure out how can we perform operations, so addition, subtraction, and multiplication specifically, on polynomials. And we'll start with a few definitions. So first we want to know what a polynomial is. So we already know what a monomial is. Remember, monomials are things like these. They are things that can be written as numbers, variables, or the products of numbers and variables. And remember that the important part about this was that any exponents had to be whole numbers. So for example, we couldn't have like a -3 for an exponent, or a pi for an exponent, or a √2 for an exponent. So here you've got 5 different monomials. So to turn something into a polynomial, a monomial is actually a polynomial. But what we want to do is we would just change these to addition problems. Now it could be subtraction as well. Remember that subtracting is technically the same thing as adding the opposite. So it doesn't matter whether these terms are connected by addition or subtraction. But by taking those individual monomials and connecting them with addition or subtraction, that's what makes a polynomial. And a polynomial is written in standard form if we look at the exponents and the degree, which we'll define a little bit more clearly in just a moment. But basically that has to do with the exponents here. So for this ax squared, the x squared, the 2 is the exponent, the bx. There's no exponent written there, but that's really like a b to the first power. And then the c, that doesn't have any exponents or any x terms, so that's like x to the 0. So if you have the variable part in such an order so that the exponents go from highest to lowest like that, that's how you would write something in standard form. So coming back to this idea of degree a little bit more clearly, we said that this has to do something with the exponent. So there are a couple of specific names that we interpret here. So the first degree is linear, and an example of that is 2x plus 1, and that's because the variable part, the x, has an exponent of 1. So even though it's not written, that's like x to the first power. Quadratic is degree 2. So if we look at this second one, there's an x squared and a 3x to the first. And out of a 2 as an exponent and a 1 as an exponent, the 2 is the larger number, so this is degree 2. So you always use the largest one. If you have degree 3, that is a cubic. So here we have an x cubed, an x to the first, and then the constant at the end, remember, technically would be like x to the 0. There are no x's in that term. And out of 3, 1, and 0, 3 is the highest, so that's degree 3, or cubic. And degree 4 is quartic, so x to the 4th is quartic. Now just kind of a side note, if you see anything that has multiple variables, so like if you had 2x squared y cubed, this has degree 5. And the way we figure that out is that we look at all of the variable exponents and we add them. So x squared has degree 2, y cubed has degree 3, 2 plus 3 is 5. And we don't have a special name for degree 5. Technically it would be quintic, but really if you just know the first 4, so linear, quadratic, cubic, quartic, that's good enough. And then after that you can just say degree 5, degree 6, degree 7, etc. Now just like there were different names for degrees, there are also different names for the number of terms in a polynomial. So we said that a polynomial is the sum of multiple monomials, one or more monomial. So if there's only one term, we call it a monomial. So 2x is a monomial, xyz is a monomial, -5 is a monomial. If there are two terms, now the important thing is this is after you simplify it, so we want them to be unlike terms, and that's connected with addition or subtraction. That's a binomial. So 2x minus 4 is a binomial. X plus y is a binomial. And if there are three terms, we call that a trinomial. So x squared plus x minus 11 is a trinomial. And again, we don't have any special names for anything above that. So if you have something with 4 terms, you would just call it a polynomial with 4 terms. All right, our next vocabulary word is the leading coefficient. So you already know that the coefficient is the number that's in front of the variable part of a term. And in polynomials, we know there are sometimes several terms. For example, a trinomial has 3 terms. So to find the leading coefficient, you're going to look at the 3 terms in that case, for example, and you're going to find the term with the highest degree, and you want the coefficient of that term. So if we had 3x cubed minus 2x plus 1, that's a trinomial. The 3x cubed has degree 3, the 2x has degree 1, the 1 has degree 0. The 3x cubed is the one with the highest degree, so that is a degree 3 because it's the number in front of the x cubed term. So next up, we'll do a couple of practice problems here, combining all of this together. So what's the type? So is it a monomial, binomial, trinomial, etc.? What's the degree? So is it linear, quadratic, cubic, quartic, 5th degree, etc.? And what's the leading coefficient? For each of these, try pausing the video if you feel ready before you see the answer. So let's start with 8x. 8x has 1 term, so it's a monomial. The x is to the first power, so it's linear or 1st degree. And the number in front of the x is an 8, so its leading coefficient is 8. For 10x minus 5, that's a binomial. It's got 2 terms. It still has a highest degree of 1, x to the first power, so it's still linear. And the number in front of the x is a 10, so it's got a leading coefficient of 10. X squared minus 4x plus 4, that's a trinomial because it's got 3 terms. The highest exponent on the x's is a 2, so it's 2nd degree or quadratic. And the number in front of the x squared, remember if there's no number written there, it's a 1. It's a 1x squared. Next we have negative 24 minus x cubed. That's 2 terms, so it's a binomial. Highest exponent is a 3, so it's cubic. And be a little careful here. The number in front of the x cubed, you've got that minus sign there, and then no number, so that's like a -1. All right, and this is our last vocab term for this video, is the concept of like terms, which you've seen in the past. They're just going to look a little bit more complicated in this section because we have more variables to deal with. So, a like term just means that it has the exact same variable part. So 2x and -7x, those are like terms. X squared and 4x squared, those are like terms. So 2x and x squared, those are not like terms. Even though they both have x's, they're not exactly the same because one is an x and one is an x squared. So it has to have identical variable parts. So here's an example. We've got 3a squared b, 4ab squared, 3ab, and -5ab squared. And we want to figure out which of these are like terms. Now they all have a's and b's, but we need the exponent parts to be the same as well. And the ab squareds, those are the same for the 4ab squared and -5ab squared. So those are our like terms. So that's it for this video, and we'll see you on the next one. Bye!